ideas from my point of view. This thing coupled up to the screen. There we go. But ideas are everywhere. This is a probably true enough statement, all right? Finished files are the results of years of scientific study combined with the experience of years of research. Probably not the best worded sentence, but the point is not the actual message there. But I have a question for you. How many F's are in that sentence? How many times do you see the letter F? It's not a trick question. Okay? You ready? I'm going to take a survey. You ready?
6.
How many see it 3 times? No more than 3 times. How many see it 5 times and no more than 5 times? How many see it 6 times? How many see it 7 times? Those are the geniuses in the crowd. And we just recognized a problem. The problem, by the way, is with our neuroscience wiring up here. What F's didn't you see? The U's. The U's. You didn't see the U's. This has been going. This particular trick has been going around. I first saw it 30 years ago, and I haven't heard, outside of the fact that your brain is wired to see to ignore the F and the U's. You think of them I'm told, you think of them in your mind as V's. I don't know whether that's true or not, but there's a topic for research, is it not? And, hasn't been solved yet that I'm aware of, but you can go search on it to see what's going on. They claim nowadays, one website, Google is great for information. Can you believe it? Sometimes you can believe what you're reading on. When you Google on something, you better check it against something else and check against something else. There's a lot of utter nonsense on the website as well. The answer to the why your brain is doing this ranges from those of you that spotted all 7 are pure geniuses. That's one version of it. You may think differently, though. You may think more you may be great computer scientists, for example. You see every character in your brain as you're writing a line of code. What gives here? You all have a right leg, I think. Take your right leg and start moving it in a clockwise circle. Okay, once you get that going, take your right arm or right hand, and I want you to draw the letter 6. What happens to your leg? Yeah, I just saw this one this week. My wife just pointed this trick out to me. What's going on here? We see plenty of problems. There's plenty of problems to solve. We got a lot of them right up here. But these are problems in how we learn things and how we do things. What if we tried the same trick? I haven't tried this, but go home and work on this one. Do the same thing on your left with your left leg and left hand. If I make them both in the same direction, what happens? Now, just really kicks. Move your right foot clockwise. Move your hand clockwise in a circle. Does that work okay for you? I think it works okay for you. So, we already we can enter that in the fair. It's a pretty good project. Of course, we don't know why we're doing what we're doing. Right. So my point is, I threw these 2 at you so you can go home and amaze your friends. But beyond that, ideas are everywhere. And that's 2 perfect examples of in an area I know nothing about. I'm an electrical engineer, laser engineer, quasi-scientist. I worked on the fringe for many years at United Technologies Research Center. Got my start because I won the science fair. This science fair. I won it in the Stone Age. We used to build things out of stone back in 1958 and 59. Went to the International Science Fair. Somehow I got really lucky, and the director of research at the United Technologies, back then it was United Aircraft, said, "Gee whiz, why don't you come and play in my sandbox for the summer?" I said, super, and he really meant that. I got to do anything I really wanted to do. And then it turned into real work after a while, but it still was a sandbox. So if you don't think the science fair can bring you opportunities, you'll be wrong. It does bring you opportunities, and you never know where they're coming from. Our major categories, I think you all have this information in your book, so I didn't copy the slides again, but somewhere around page 2 or so of the guide was to get into the various categories. And we have affairs divided, as you know, into life sciences and physical sciences. And the third major category, but it's a combination of everything.
There's a bus backing up.
School bus, never mind. Okay. There's a third category, which I'm happy to report that Rochelle is here today to represent Alexion Biotechnology, because my knowledge of biotechnology ends with this definition from the Merriam-Webster Dictionary, but she'll be getting into ideas there later as we get into it. How we select projects for that category is by an algorithm that looks at certain characteristics of the life science projects and feeds them into this category. In addition to that, Rochelle and her judging team from Alexion goes out and walks the floor and picks topics that are of interest to them. That's simply stated, that's how we get there from here. So it's a special major category, if you wish. If you win any of those three categories, you get to go to the International Science and Engineering Fair, be it a team project or an individual project. Teams are coming on stronger and stronger these days, so you got to watch out for the teams as well. Ideas for special category consideration. In addition to those major project categories, we have a rich number of special categories. And if you play to the interests of these categories, you stand a chance to be looked at very hard by at least one of them. And I'll go through a few. For example, the hottest thing going right now in the United States and probably the world is alternative renewable energy. For some reason, Wisner wrote energy twice here. We'll ignore that error. But for projects that best promote an educated, energy-conscious society. So, what ideas would be helpful there? Well, measuring efficiency of lighting sources. LED lighting. Is LED lighting as good as they claim? I think it'll really last 50,000 hours, that magical source of light. Is it? You know, right now, compact fluorescent light bulbs are going to replace all incandescent bulbs, right? By law, in fact. Compact fluorescent light bulbs contain what gas? Anybody guess? Fluorescent light, what makes it light up? They ionize mercury. So, on the one hand, in your science lab in school, you can see the silliest situation. You can see somebody spilling a pinprick of mercury on the floor, and it will shut the school down, while the janitor is chucking fluorescent light bulbs in the trash can in the back, in the back room. There's mercury in every one of those tubes. So, is that a good thing or a bad thing? Well, if you looked at that problem, you looked at the light, it might be an environmental issue, and it might lap over into the environment. Many things that you do for power generation these days waste a lot of power, so you want to increase the efficiency. In my last 5 years of my career with United Technologies, I ran a group at Otis Elevator, working on the electronic drives and the motors that run the elevators. Do elevators always consume power when they're moving? What's your guess? Well, you would guess that, and it maybe takes a little bit to get them started. But what if the elevator is balanced? There's an elevator car, steel ropes. On the other side of the steel ropes, we call them ropes, is a counterbalance. To counterbalance the weight of the ropes and the elevator cab and the people that are in it. gets in the elevator. You think you need power to get it down to the first floor? No, it's going to go to the first floor. Actually, it's going to generate power. So my big crusade during the years that I was working at Otis was to build regenerative electronics that would extract the power from the motor and put it back into the power grid to run the other elevators that needed the power. So there's a whole line right now. It only took a while to convince management because it cost a little more. Now it's an important thing to do, and they're praising it, and you find it everywhere on the website. It's a very important issue, and that's reclaiming power. When I drove my Prius, I didn't drive my Prius here today. I got a ride from my colleague. But if I drove my Prius here today and I step on the brake, what does a regular car do when you step on the brake? Squeezes something. No, actually it squeezes that disc or drum behind the tires with a pad made of some hard materials, the brake pads. Right, just like it squeezes it, and what happens? Where does the energy go that's going? It turns into heat. If you're going down a mountainside in a car and you keep your brakes on, those things will smoke and burn up. Well, you get in the Prius, you go down the hill, you charge the battery. Because when you step on the brake in the Prius, the first thing it does is the motor becomes a generator and starts charging the bank of batteries. So there are all these neat ideas everywhere surrounding you in energy. You just have to think about the problem a little bit, and I bet you can find something to address. Applied technology is another category. Almost anything you do to use it, come up with a practical solution to a problem you're looking at, may be of interest to the judges for this category. It's a real broad, reaching one. Computer science. If you're doing something, if you're a computer code writer, if you're working on a new internet page, building your new social network, you're building an app for your iPhone or iPad, boy, you're going to get their attention real fast. And it's got the wrong definition. You know, it was late last night when we made the slide. That's the mathematics definition. In engineering, projects in the disciplines of electrical, mechanical, electro-optic, and optical engineering. What's the difference between an engineering project and a normal research project? Well, in an engineering project, you really don't have, quote, a hypothesis. You don't use the scientific method. What you do is you have an engineering objective. I need a way to light this room by using 50% less electricity. That might be your objective. And you come up with a series of steps based on existing technology that walks you through to a different answer. That's an engineering project. That's the big difference. So I was just a lowly engineer in my career. We always had a problem statement. Scientists start with very abstract problems and highly abstract. Goodrich is interested in engineering.